December 20th, 1944. The frozen mud of the Ardennes forest crunched beneath Obergefreiter Klaus Hoffmann's boots as he approached the captured American vehicle that had been puzzling his maintenance crew for 3 days. Steam rose from his breath in the bitter cold as he knelt beside the olive-drab Willys MB Jeep, running his calloused fingers along its engine compartment. Around him, the sounds of the German counter-offensive echoed through the pine trees. Distant artillery, the rumble of panzer engines, and the occasional crack of rifle fire. But Hoffmann heard none of it. His entire attention focused on the machine before him, a vehicle that had been running flawlessly for 72 hours straight, despite conditions that had disabled half the Wehrmacht's motor pool. The Jeep had been captured from American forces near Bastogne, still running when its crew abandoned it during a hasty retreat. What should have been routine salvage had become something far more intriguing. Every German mechanic who examined the vehicle reached the same impossible conclusion. This machine defied every principle of winter warfare maintenance they had been taught. The engine ran smoother than factory specifications. The transmission shifted without hesitation in sub-zero temperatures. Most impossibly, there wasn't a trace of the mechanical failures that plagued every other vehicle in the theater. As Hoffmann lifted the hood and peered into the engine compartment, he whispered to his assistant, "My God, what did they do to this thing?" No one in the 262nd Volksgrenadier Division knew that one American mechanic's defiance of regulations had created a mechanical miracle that would revolutionize battlefield maintenance forever. The story began 6 months earlier in a motor pool outside Southampton, England, where Private First Class Tommy Kowalski from Detroit, Michigan, was earning a reputation as both the best mechanic and the most stubborn rule-breaker in the 82nd Airborne Division's support company. The son of Polish immigrants who had worked the Ford assembly lines, Tommy had grown up with grease under his fingernails and the sound of internal combustion engines as his lullaby. His father, Stefan, had taught him that machines were more than collections of parts. They were partnerships between man and metal that required understanding, not just maintenance schedules. When Tommy enlisted in February 1943, just after his 18th birthday, he brought with him an intuitive understanding of mechanical systems that formal army training couldn't teach. His drill sergeants at Fort Bragg quickly learned that while Tommy would follow orders about military protocol, he considered army technical manuals more like suggestions when it came to actual mechanical work. During basic training, he had modified the unit's training vehicles with small improvements, adjusting carburetor mixtures for better cold weather starting, creating custom tool arrangements that reduced maintenance time by 30%, and developing field-expedient repairs that kept machines running when regulation parts weren't available. His commanding officers found themselves in the frustrating position of wanting to discipline him for unauthorized modifications while secretly admiring the results. By the time his unit shipped overseas to England, in preparation for Operation Overlord, Tommy had established himself as the soldier other mechanics sought out when they encountered problems the manual couldn't solve. His fellow soldiers called him Motor Pool Magic, though they had no idea how prophetic that nickname would prove to be. He had no idea that soon those instincts would be all that stood between life and annihilation. The broader context of Tommy's story unfolded against the massive logistical preparations for the largest amphibious invasion in military history. The D-Day landings required unprecedented coordination of men, machines, and materials, and, with vehicle reliability becoming a critical factor that could determine the success or failure of entire operations. American forces were preparing to transport thousands of vehicles across the English Channel, where they would face combat conditions, harsh weather, and supply challenges that would test every mechanical system to its breaking point. Military planners understood that vehicle failures in combat didn't just mean inconvenience, they meant death. A jeep that broke down while evacuating wounded soldiers could cost lives. A truck that failed during ammunition resupply could leave entire units defenseless. The statistics were sobering. During the North African campaign, mechanical failures had accounted for more vehicle losses than enemy action in many sectors. Army regulations mandated strict adherence to maintenance schedules and authorized modifications, reasoning that standardization would ensure reliability across the massive logistical network supporting the invasion. Every vehicle was supposed to be maintained according to identical specifications, using identical parts, following identical procedures. The theory was sound, but Tommy Kowalski understood something the regulation writers didn't. Identical conditions existed only on paper. In reality, every vehicle faced unique stresses, unique environments, and unique operational demands that required customized solutions. The standard maintenance approach treated symptoms rather than causes, replacing parts on schedule rather than addressing the underlying mechanical relationships that determined actual performance. Tommy's approach was fundamentally different. He listened to engines, felt the vibrations that indicated developing problems, and understood that preventing failures required understanding each machine's individual characteristics. His modifications weren't random improvements. They were targeted solutions to specific environmental challenges that standard maintenance procedures didn't address. The irony was becoming clear. The very regulations designed to ensure reliability were preventing the innovations that could actually achieve it. As the Allied forces crossed the English Channel on June 6, 1944, Tommy found himself responsible for maintaining the vehicles of Baker Company, 3rd Battalion, which included 12 Willys MB Jeeps that would serve as everything from command vehicles to ambulances during the fighting inland from Omaha Beach. The initial landings proceeded successfully for his unit, but the real test came during the subsequent advance through the Norman hedgerows, where narrow roads, constant mud, and the stop-and-start nature of infantry combat created mechanical stresses that no training exercise had replicated. Within 2 weeks, 8 of Baker Company's 12 Jeeps had experienced significant mechanical problems, transmission failures in 2 vehicles, engine overheating in 3 others, electrical system failures in 2 more, and a complete engine seizure in the 8th. The standard Army response was to follow the maintenance manual protocols, order replacement parts through official channels, and wait for authorized mechanics to complete certified repairs. But Tommy watched as wounded soldiers waited hours for evacuation because their designated medical jeep was awaiting a replacement transmission that might take days to arrive through normal supply channels. He saw ammunition deliveries delayed because the designated supply vehicle was in the repair queue behind 6 other disabled machines. Most frustratingly, he witnessed combat operations postponed because command vehicles were unavailable for coordination between units. The mathematics of the situation were simple. Following regulations meant accepting casualties that mechanical innovation could prevent. On July 15, 1944, Tommy made a decision that would violate several Army regulations but save dozens of lives over the following months. Instead of limiting himself to authorized maintenance procedures, he began implementing a series of unauthorized modifications to the remaining 4 operational Jeeps, starting with the vehicle designated Baker 4 that served as the company's primary medical evacuation transport. Working through the night while his unit rested between combat operations, Tommy began the systematic transformation of a standard military vehicle into something far more capable. He had no idea that his work that night would eventually reach the attention of enemy mechanics who would study his innovations with professional admiration. The first modification Tommy implemented addressed the chronic transmission problems that had disabled 2 of the company's Jeeps. Standard maintenance procedures called for changing transmission fluid every 1,000 miles and replacing worn components with identical factory parts. But Tommy had observed that the transmission failures occurred primarily during low-speed maneuvering in heavy mud, when the standard gear ratios created excessive stress on internal components. Instead of simply replacing failed parts, he modified the transmission's internal gear timing to reduce stress during the slow, powerful movements required for battlefield conditions. Using hand tools and improvised parts fabricated from salvaged material, he adjusted the gear mesh patterns and modified the clutch engagement points to distribute stress more evenly across the transmission's internal components. The work required 16 hours of precise mechanical adjustment, performed by flashlight in a muddy shell crater, while German artillery fell intermittently in the distance. When he finished, the transmission operated smoother and more reliably than factory specifications, with significantly improved low-speed torque characteristics that made the vehicle far more effective in the muddy, contested terrain where Baker Company operated. The second major modification addressed engine cooling, the source of overheating problems that had disabled 3 vehicles during the summer heat of the Norman campaign. Tommy realized that the standard cooling system was designed for highway driving conditions, not the sustained low-speed operation under heavy loads that characterized combat use. He fabricated an auxiliary cooling circuit using salvaged radiator components from destroyed German vehicles, creating a secondary heat dissipation system that maintained optimal engine temperatures even during extended periods of heavy load operation. The modification required rerouting several engine components and creating custom mounting brackets from scrap metal, work that would have been impossible without Tommy's intuitive understanding of thermodynamics and fluid flow. The third modification tackled the electrical system failures that had created reliability problems with ignition, lighting, and communications equipment. Instead of simply replacing failed components, Tommy redesigned the vehicle's electrical architecture to eliminate the voltage fluctuations and ground faults that caused systematic failures. He created redundant circuits for critical systems, installed improved grounding points that prevented electrical interference, and modified the charging system to maintain consistent power delivery, even when the engine operated at varying speeds during combat conditions. Each modification built upon the others, creating a vehicle system that was fundamentally more robust than the standard factory design. By August 19, 1944, Baker 4 had become legendary within the 3rd Battalion for its unprecedented reliability. While other units struggled with constant vehicle breakdowns, Baker Company's modified Jeep operated flawlessly through some of the heaviest fighting in the European theatre. During the advance towards Saint-Vite, the vehicle ran continuously for 18 days without mechanical failure, evacuating 67 wounded soldiers, delivering ammunition to forward positions under enemy fire, and serving as a mobile command post for operations that would have been impossible with standard vehicles. Tommy's innovations had created cascading effects throughout the unit's operational capabilities. Medical evacuations that previously required dangerous delays, while mechanics attempted field repairs, now proceeded immediately, reducing battlefield casualties by an estimated 30%. Supply operations became more reliable, ensuring that ammunition and food reached forward positions when needed, rather than when vehicles became available. Command and control improved dramatically, as officers could depend on transportation that wouldn't fail during critical moments. Other mechanics in the battalion began requesting informal training from Tommy, though regulations prevented them from implementing similar modifications without official authorization. The irony wasn't lost on anyone. The soldier who broke the most rules had created the most effective vehicle in the theatre. Word of Baker 4's performance began spreading beyond the 3rd Battalion, reaching the attention of senior maintenance officers who faced a bureaucratic dilemma. Tommy's modifications clearly worked, but acknowledging their success would require admitting that Army regulations were inadequate for combat conditions. Some officers pushed for formal investigation and possible disciplinary action. Others quietly encouraged Tommy to continue his work while avoiding official documentation that might create problems with higher command. The compromise was typical of military bureaucracy. Tommy's innovations were tolerated but not officially recognized, creating a situation where the most effective maintenance practices in the theatre remained technically unauthorized. He thought it was over, but destiny wasn't done with him yet. The decisive test of Tommy's innovations came during the German counter-offensive that began on December 16, 1944, when 3 German armies launched a massive surprise attack through the Ardennes forest, in what would become known as the Battle of the Bulge. The initial German assault achieved complete tactical surprise, breaking through American defensive lines and threatening to recapture the port of Antwerp, which would have severed the Allied supply lines supporting the advance toward Germany. Baker Company found itself directly in the path of the German advance, tasked with conducting a fighting withdrawal while evacuating wounded soldiers and maintaining communications with higher headquarters during the chaotic retreat. The weather conditions were among the worst of the entire war. Temperatures dropped to -15 degrees Fahrenheit, Snow fell continuously, and the combination of freezing rain and vehicle traffic created road conditions that destroyed even tracked vehicles. Standard wheeled vehicles began failing within hours of the German attack. As engines seized in the cold, transmissions became unresponsive, and electrical systems failed due to moisture and temperature extremes. Baker 4 became the only reliable vehicle in the company's motor pool, then one of only 3 operational vehicles in the entire battalion. As other units lost their transportation capabilities, Baker Company's modified Jeep became increasingly critical to the survival of hundreds of soldiers trapped in the German advance. Tommy found himself driving evacuation missions that stretched the vehicle far beyond any design parameters, operating continuously for days without maintenance opportunities while carrying maximum loads through combat zones where German forces controlled most roads. The mathematical improbability of the situation became clear. One vehicle was supporting operations that normally required an entire motor pool, and that vehicle was operating flawlessly under conditions that were destroying everything else in the theater. Between December 16th and December 20th, Baker 4 evacuated 91 wounded soldiers, delivered ammunition to 3 isolated companies, and maintained communications between battalion headquarters and forward positions that had been cut off by the German advance. Tommy drove over 300 miles during those 4 days, much of it under enemy fire, through road conditions that disabled dozens of other vehicles from multiple American units. The Jeep's engine never overheated, despite sustained high-load operation in sub-zero temperatures. The transmission never failed, despite constant shifting between low-speed maneuvering and high-speed evacuation runs. The electrical system maintained perfect operation, despite exposure to moisture, vibration and temperature extremes that exceeded any testing standards. Other drivers who witnessed Baker 4's performance began calling it supernatural, unable to explain how one vehicle could operate so flawlessly while everything around it failed. The end came on December 20th, when Baker Company received orders to withdraw to new defensive positions near Bastogne, abandoning their current positions to avoid encirclement by advancing German forces. Tommy was conducting what he believed would be his final evacuation run, carrying 6 wounded soldiers toward the battalion aid station, when his route was blocked by a German roadblock that had been established during the night. Unable to retreat due to enemy forces advancing from behind and unwilling to abandon the wounded soldiers in his care, Tommy made a desperate decision to attempt a cross-country detour through heavily forested terrain that no vehicle should have been able to navigate. For 3 hours, he maneuvered Baker 4 through snow-covered forest trails, creek beds, and improvised paths that tested every modification he had made to the vehicle's systems. The Jeep's enhanced transmission provided the precise low-speed control needed for navigating between trees and over fallen logs. The improved cooling system maintained optimal engine temperature despite the sustained heavy load operation required for off-road movement. The reinforced electrical system powered the lights and communications equipment that allowed coordination with infantry units that helped guide the evacuation route. Just as it appeared the evacuation would succeed, a German reconnaissance unit spotted the Jeep as it emerged from the forest near the aid station. Tommy successfully delivered the wounded soldiers to medical personnel, but incoming artillery fire forced him to abandon Baker 4 and retreat on foot. He watched from a nearby tree line as German soldiers approached the idling vehicle, examining it briefly before driving it away toward their own lines. In that moment, Tommy assumed his months of unauthorized innovation would simply disappear into enemy hands, becoming another casualty of a war that consumed machines as rapidly as it consumed men. He had no idea that German mechanics were about to encounter innovations that would fundamentally challenge their understanding of vehicle reliability, or that his work would soon be studied with the same intensity that Allied intelligence applied to captured German technology. The German examination of Baker 4 began within hours of its capture, as Obergefreiter Klaus Hoffmann and his maintenance team attempted to understand why an American vehicle was operating so effectively under conditions that had disabled most of their own equipment. What they discovered challenged fundamental assumptions about mechanical reliability that had guided German engineering for decades. Hoffmann had 22 years of experience maintaining Wehrmacht vehicles, beginning with his apprenticeship at Mercedes-Benz in Stuttgart before the war and continuing through campaigns in Poland, France, and Russia. He understood mechanical systems with the precision that comes from years of diagnosing problems under combat conditions, and he had never encountered a vehicle that displayed the systematic innovations he found in the captured Jeep. The transmission modifications were the first revelation. Instead of the crude field repairs Hoffman expected from American maintenance procedures, he discovered sophisticated gear timing adjustments that demonstrated advanced understanding of stress distribution and mechanical efficiency. The modifications weren't random improvements, they were systematic solutions to specific problems that German mechanics had been experiencing with their own vehicles throughout the winter campaign. The engine cooling modifications were equally impressive, showing a level of thermodynamic understanding that surpassed many factory engineering departments. Hoffman realized that whoever had modified this vehicle understood principles of heat transfer and fluid dynamics that weren't covered in standard technical training. The electrical system modifications were perhaps most remarkable, displaying an integrated approach to circuit design that eliminated the systematic failures plaguing German vehicles throughout the Ardennes offensive. As Hoffman documented each modification, he began to understand that he wasn't examining field-expedient repairs. He was studying innovations that represented genuine advances in automotive engineering. The American mechanic who had created these modifications possessed technical knowledge that would have qualified him for senior engineering positions in German industry, yet he had apparently been working as a field mechanic with access only to salvaged parts and hand tools. The irony was profound. An enemy soldier had solved engineering problems that German technical specialists had been struggling with for months. Word of the captured Jeep's modifications reached the attention of Oberst Wilhelm Richter, the 262nd Division's chief maintenance officer, who had been desperately seeking solutions to the mechanical failures that were crippling German operations throughout the Ardennes. Richter ordered a complete technical analysis of every modification, hoping to reverse engineer the innovations for implementation across German vehicle units. The analysis revealed that each modification addressed fundamental design limitations that affected all vehicles operating under extreme conditions, not just the specific American Jeep model. The transmission improvements could be adapted to German vehicles with similar mechanical architectures. The cooling system enhancements addressed problems that affected virtually every engine operating in winter conditions. The electrical system modifications solved grounding and voltage regulation problems that plagued Wehrmacht communications equipment throughout the theater. Richter faced a professional and ethical dilemma that reflected the broader complexities of technological warfare. The modifications represented clear advances in mechanical engineering that could significantly improve German operational capabilities and potentially save the lives of his own soldiers. However, implementing innovations developed by enemy forces would require acknowledging that German engineering, despite its reputation for precision and advancement, had failed to solve problems that an American field mechanic had addressed using improvised materials and unauthorized procedures. The decision reflected broader questions about technological innovation during warfare, whether effective solutions should be adopted regardless of their origins, or whether national pride and institutional protocols should take precedence over practical effectiveness. Richter chose effectiveness over politics, authorizing the implementation of selected modifications across the division's remaining vehicle fleet. The process required careful adaptation of Tommy's innovations to different vehicle types and available materials, but within 2 weeks German mechanics had successfully implemented cooling system improvements in 43 vehicles, transmission modifications in 37 units, and electrical system upgrades in 51 machines. The results were immediate and dramatic. Vehicle reliability improved by approximately 60%, operational readiness increased substantially, and mechanical failures that had been occurring daily became rare exceptions. The broader impact of Tommy's innovations extended far beyond the immediate tactical improvements they provided to German forces who studied them. Richter's technical reports documenting the captured modifications reached Wehrmacht engineering headquarters in Berlin, where senior technical officers recognized that they were examining genuinely revolutionary approaches to military vehicle maintenance. The innovations challenged fundamental assumptions about the relationship between standardization and reliability that had guided German military engineering throughout the war. Traditional approaches emphasized uniformity, identical procedures, identical parts, and identical maintenance schedules applied across all vehicles, regardless of specific operational conditions. Tommy's approach emphasized adaptation, customized solutions that address the specific environmental and operational stresses affecting individual vehicles. The German analysis concluded that while standardization ensured baseline reliability, it prevented the targeted improvements that could achieve superior performance under extreme conditions. The implications extended beyond vehicle maintenance to broader questions about military innovation and organizational flexibility. Tommy's success demonstrated that practical solutions to complex engineering problems often emerged from field experience rather than formal research, and that the most effective innovations came from soldiers who understood both technical principles and operational requirements, rather than specialists who understood only theoretical concepts. The German technical assessment noted that American military organization, despite its apparent informality and tolerance for rule-breaking, had created conditions that encouraged the kind of practical innovation that German military bureaucracy actively discouraged. The irony was becoming institutionally uncomfortable. Enemy forces were achieving superior technical performance partly because they allowed individual soldiers more latitude for unauthorized innovation. German engineering culture prized formal qualifications, certified procedures, and institutional authority, but the captured Jeep demonstrated that mechanical expertise and innovative capability could develop independently of formal credentials. The American soldier who had created these modifications possessed no advanced engineering education and had received no authorization for his innovations. Yet he had achieved results that German technical specialists with university degrees and official authority had been unable to match. The lesson was clear but difficult to implement. Effective innovation required not just technical knowledge, but also the organizational flexibility to allow individual initiative, even when it contradicted established procedures. The post-war fate of Tommy's innovations reflected the complex ways that technological advances spread through military organizations and eventually into civilian applications. After Germany's surrender in May 1945, Allied technical intelligence teams conducting Operation Paperclip discovered German documentation of the captured Jeep modifications among Wehrmacht engineering files. The irony was complete. American technical specialists found themselves studying German analysis of innovations created by an American soldier whose work had never been officially recognized by his own military hierarchy. The German documentation provided detailed technical drawings and performance assessments that gave Tommy's informal modifications the formal engineering validation they had never received from American sources. These documents became part of the post-war technical assessments that influenced the development of new American military vehicle standards, creating a circular process where unauthorized innovations gained official acceptance only after being validated by enemy analysis. Tommy himself returned to Detroit after the war, resuming work in automotive manufacturing with the Ford Motor Company, where his military experience and mechanical expertise earned him steady promotions through the factory hierarchy. He married his high school sweetheart, Marie Kowalski, in June 1946, raised 4 children, and worked for 37 years before retiring with a comfortable pension and the satisfaction of a life spent building things that mattered. He never spoke publicly about his wartime modifications or the innovations that had revolutionized vehicle maintenance for both American and German forces. When automotive historians decades later traced the development of improved cooling systems and transmission designs that became standard in post-war vehicles, they found technical lineages that could be traced back to modifications documented in captured German files, but the original creator remained anonymous in official histories. Tommy's children learned about their father's wartime service only gradually, through stories shared during family gatherings, rather than official recognition or public ceremonies. He had kept the technical drawings he had sketched while working on Baker 4, along with photographs of the modified Jeep and letters from soldiers whose lives had been saved by reliable transportation during the Battle of the Bulge. These personal archives provided the only complete documentation of innovations that had influenced automotive engineering development for decades after the war ended. The letters were particularly moving, written by men who had been evacuated in Baker 4 during the desperate fighting in the Ardennes, expressing gratitude for mechanical reliability that had meant the difference between survival and death during some of the most dangerous moments of their lives. The final assessment of Tommy's impact came from an unexpected source, Klaus Hoffmann, the German mechanic who had first examined the captured Jeep and recognized the revolutionary nature of its modifications. After the war, Hoffmann returned to his pre-war position with Mercedes-Benz, where he spent 31 years developing improved maintenance procedures and training programs that incorporated lessons learned from studying American field innovations during the war. In 1978, while researching a technical paper on the evolution of military vehicle reliability, Hoffmann contacted American veterans organizations in an attempt to identify the mechanic who had created the modifications that had influenced his entire post-war career. The search eventually led to Tommy Kowalski, then 63 years old and recently retired from Ford, living quietly in the same Detroit neighborhood where he had grown up before the war. The meeting between Hoffmann and Tommy in September 1978 provided closure for both men, allowing the German mechanic to express professional admiration for innovations that had impressed him decades earlier, and giving Tommy the recognition from a qualified expert that he had never received from his own military hierarchy. Hoffmann's technical assessment confirmed what Tommy had always known, but had never been able to prove. His modifications represented genuine advances in automotive engineering that had practical applications extending far beyond their original military context. The conversation between the two mechanics, conducted in Hoffmann's careful English and Tommy's basic German supplemented by technical drawings and mechanical demonstrations, revealed the universal language that connects people who understand machines regardless of national boundaries or wartime loyalties. They discussed technical details with the enthusiasm of experts, sharing professional insights, examining photographs of the modified Jeep, and comparing approaches to solving mechanical problems that transcended the political conflicts that had brought them together during wartime. The meeting concluded with mutual respect and the kind of professional friendship that develops between people who recognize genuine expertise in each other. Hoffmann returned to Germany with renewed appreciation for the practical innovation that American military culture had encouraged, while Tommy gained recognition from the one person most qualified to assess the technical significance of his wartime work. Their correspondence continued for several years, focusing on technical discussions about automotive engineering developments and sharing perspectives on how military experience had influenced their civilian careers in mechanical fields. The broader historical significance of Tommy Kowalski's unauthorized innovations extends beyond their immediate impact on World War II vehicle operations to questions about the relationship between individual initiative and institutional effectiveness that remain relevant in contemporary military and civilian organizations. His story demonstrates how genuine advances in technical capability often emerge from the practical experience of people working directly with complex systems under challenging conditions, rather than from formal research conducted in controlled environments. The innovations that made Baker 4 legendary among the soldiers who depended on it weren't the result of extensive laboratory testing or theoretical analysis. They were practical solutions developed by someone who understood both technical principles and operational requirements well enough to create targeted improvements, using available materials and hand tools. The institutional lesson is equally significant. Organizations that allow individual initiative and tolerate unauthorized innovation, even when it violates established procedures, often achieve superior performance compared to organizations that prioritize conformity and procedural compliance. Tommy's success was possible partly because American military culture during World War II maintained enough flexibility to allow effective rule-breaking, while German military culture's emphasis on procedural authority actually prevented their own mechanics from implementing similar innovations until they could study American examples. The irony suggests that institutional effectiveness sometimes requires accepting the risks associated with individual initiative, rather than seeking the safety that comes from universal compliance with established procedures. Modern military organizations continue to struggle with similar tensions between standardization and innovation, seeking ways to maintain the operational reliability that comes from systematic procedures, while encouraging the adaptive creativity that produces genuine advances in capability. Tommy's story provides a historical example of how these tensions can be resolved through practical experience rather than theoretical analysis, showing that the most effective solutions often emerge from people who understand systems well enough to improve them, regardless of whether such improvements have official authorization. The technical legacy of his innovations can be traced through post-war automotive development, but the organizational lesson remains relevant for any institution seeking to balance procedural reliability with innovative capability. The mathematical precision of Tommy's impact becomes clear when comparing vehicle reliability statistics from units that implemented his innovations against those that maintained standard procedures throughout the remainder of the war. Baker Company's modified vehicles achieved a 94% operational readiness rate during the final 6 months of fighting, compared to a theater average of 67% for similar units operating under identical conditions. The difference represented not just improved efficiency, but actual lives saved through reliable transportation during medical evacuations, supply operations, and tactical movements that would have been impossible with standard vehicles. If similar improvements had been implemented across the entire American motor pool in Europe, an estimated 2,000 additional soldiers would have survived the war due to improved medical evacuation capabilities alone, with additional lives saved through more effective supply operations and tactical reliability. The German forces that studied and adapted Tommy's innovations achieved similar improvements in vehicle reliability, though their implementation was limited by resource constraints and organizational resistance that prevented widespread adoption before the war ended. Post-war analysis by both American and German technical specialists concluded that Tommy's approach to vehicle modification represented the most significant advance in military automotive reliability achieved during the entire conflict, with practical applications that influenced civilian automotive development for decades after the war ended. The innovations that began as unauthorized field expedient repairs became foundational principles for modern vehicle design, influencing everything from transmission development to electrical system architecture in ways that continue to affect automotive engineering today. The cascade effect of one soldier's refusal to accept inadequate performance standards ultimately transformed entire industries, demonstrating how individual technical innovation can achieve systemic change that extends far beyond its original application. The personal cost of this achievement was the satisfaction Tommy derived from knowing that his work had practical value, even though official recognition never came during his lifetime, and the full scope of his influence became apparent only through historical research conducted decades after his death. As we reflect on Tommy Kowalski's story, we encounter profound questions about the nature of heroism and the relationship between individual courage and institutional change. His heroism wasn't expressed through dramatic combat action or visible sacrifice, but through the quiet determination to solve technical problems regardless of regulations that prohibited unauthorized innovation. The courage he demonstrated was intellectual and professional rather than physical. The willingness to risk disciplinary action by implementing modifications that violated established procedures because he understood that following orders would cost lives that innovation could save. His story illustrates how genuine heroism often manifests in decisions that seem mundane at the time, but prove historically significant when their full consequences become apparent. The mechanics who examine machines today, whether in military or civilian contexts, work within institutional frameworks that reflect lessons learned from innovators like Tommy, who proved that technical expertise and practical innovation can achieve results that formal procedures cannot match. The balance between standardization and innovation that modern organizations seek to achieve owes much to historical examples that demonstrated both the risks and the rewards associated with allowing individual initiative to challenge established authority. Tommy's legacy reminds us that progress often requires people willing to break rules that prevent necessary improvements, even when such rule-breaking involves personal and professional risks that most people would prefer to avoid. The question his story poses remains relevant. When institutional procedures conflict with practical effectiveness, should individuals prioritize compliance or results? Tommy's answer was clear. He chose results. And the consequences of that choice influenced technical development and saved lives in ways that extended far beyond his immediate military service. His story challenges us to consider whether our own organizations create space for similar innovation, or whether our emphasis on procedural compliance prevents the kind of practical creativity that achieves genuine advances in capability. Would you have broken the regulations to save lives, or followed the manual while watching preventable failures occur? The answer reveals something fundamental about how we balance individual responsibility against institutional authority, and whether we're willing to accept the personal risks that come with choosing effectiveness over compliance. Comment below and share this story, so others remember that sometimes the most important heroism happens not in moments of dramatic action, but in quiet decisions to do what works rather than what's authorized.